Hello students, now we will be finding the electrical field due to a uniformly charged ring. So this is a uniformly charged ring and it is having a radius A, and now we will be finding electrical field intensity at this point P, which is at a distance of x from the center. Now for doing this we will be considering different elemental parts where the charges will be dq. So consider an element here of length dl. Now the distance between this point P and the element dl here, it is situated at the point A here. Now the distance between here and here is r, which can be given as, here there is a right angle triangle formed. Its distance can be given as r equal to root of a square plus x square. Now the angle cos theta will be x by r. Now here due to dl there is an electrical field intensity dE, this is theta and this will also be theta. Now its x axis component will be dE cos theta. Similarly, if you consider one more element dl here at point B, its electrical field intensity will be dE2 at this particular point, and again it will have dE cos theta and it will have dE sin theta. Like that, if you consider elements all over this ring, so all the dE sin theta, by symmetry all the dE sin theta components will get cancelled out and the only leftover parts will be dE cos theta components. Now so if you want the final result, so by integrating the dE cos theta you can easily find the final result. Now the charge density for this particular case can be given as charge density will be dq by dl. Now this is a linear charge density condition. Q by the total length can be given by the circumference of the circle, which is 2 pi a. So q by 2 pi a will be equal to dq by dl. From that dq will be equal to q by 2 pi a into dl. Now the electrical field intensity at point P due to dl can be given as dE1, as we have already discussed. So this will be 1 by 4 pi epsilon naught dq by the distance between this particular point and dl, which is nothing but r. So dE1 will be 1 by 4 pi epsilon naught dq by r square, which is k dq by r square. Its x axis component will be k dq by r square cos theta. Its y axis component will be sin theta, which is going to be get cancelled due to symmetry. Now the resultant field intensity can be given by integrating the result we got. So E is equal to integral k dq by r square cos theta. So k, if you take it outside being constant, so k integral 1 by r square, in the place of dq substitute the result q by 2 pi a into dl. So and in the place of cos theta you can substitute x by r. So taking these out of the integration, k by r cube qx by 2 pi a will be integral dl. So here as you can see, integrating over the total integrating over the element dl will give the total length of the ring, which is nothing but circumference of the ring, can be given as 2 pi a. So E will be k pi r cube qx by 2 pi a into 2 pi a. 2 pi a 2 pi a will get cancelled, and in the place of r you can substitute the value root of a square plus x square. R cube will be root of a square plus x square can be written as a square plus x square power 1 by 2. So cubing the so r cube will give you the result a square plus x square power 3 by 2. So the overall result will be E is equal to kqx by a square plus x square power 3 by 2. If you substitute in the place of k 1 by 4 pi epsilon naught, the result will be E is equal to 1 by 4 pi epsilon naught qx by a square plus x square 3 by 2. Now if you want to find the electrical field intensity at the center, that means if you want to find the electrical field intensity at this particular center, then you can find this logically as well as mathematically. So logically, if you see, the electrical field intensity due to all the components along the complete length of the ring will be opposite to each other, and the net electrical field intensity at the center will be 0. Now mathematically we will see, already we have derived mathematically that E is equal to 1 by 4 pi epsilon naught qx by a square plus x square 3 by 2. So at the center the value of x will be 0, because x is the distance from center of the ring to the point where you are calculating the electrical field intensity. So at the center x being 0, so the result will become, if in this particular equation if you substitute 0 in the place of x, the result will be E is equal to 0. That means you can conclude that electrical field intensity due to a uniformly charged ring at its center will be 0. E center will be 0.